Welcome my friends to my Python classes. In this video we are going to take a very simple program where we are going to learn about nested if-else. In my previous video my friends, I have shown you how to write small snippets, code snippets to implement if and else. As well as I have shown you some of the examples where if, else if also is used. Now this program is a very initial concept building program, and you will get this example in almost every classical book where you are being taught about programming. Now this program is to accept year as an input and then display whether it is a leap year or not. Now when is a year leap year? Now most of my students, when I ask them, they straight away say that the year which has 365 days is a simple ordinary year, whereas the year which has got 366 days is a leap year. Now that is perfectly fine, but how to identify just by checking that 2001 is not a leap year whereas year 2000 is a leap year, or 2020 is going to be the leap year whereas 2019 is not a leap year. Now basically the concept of leap year came when the calendars were adjusted. The calendar year actually has got a uniform structure in which a day is of 24 hours, and we usually consider that these 24 hours are the time taken by Earth to rotate on its axis, and the time taken to complete a full revolution around the Sun on its orbit is the time which we consider as year. Now if you know from your childhood that it is not exactly 365 days, in our primary education we have learned about that the complete revolution takes around 365 and 1/4 of a day. But my friends, it is not exactly 1/4 of a day, but we are having a concept that 1/4 of a day, if accumulates, the fourth year is going to get one additional day. That is 1/4 is 6 hours. So if we consider 6 hours for 4 consecutive years, we are going to get 24 hours accumulation, and that is going to be considered as one extra day in the calendar. But in fact it is not exactly 6 hours, it is 5 hours something. Please Google it to know it better. So if we are considering every fourth year to be a leap year, we will not be able to adjust it. So for adjusting it, what actually has been done, let us see. The rule is, if it is a non-century year, what is a non-century year? If the year is not having 2 zeros, that means year is not 1600 or 1700 or 1800. What is the similarity in all these years? They are having double zeros at the end. So those which are non-century year, that should be divisible by 4. But there is a separate rule for a century year. Century year should be divisible by 400. That means in a very simple way we can say that if the year is a century year, it should be divisible by 400. That means after every 4 centuries, a century year is a leap year. Whereas in case of a non-century year, it is every 4th non-century year, every 4th ordinary year is a leap year. So whenever in this, like we want to implement this problem solution, now in this problem solution we are going to accept the year as input, and our logic should be defined in such a way that it identifies whether it is a leap year or not. But according to the rules, we know that rule 1 is for a non-century year and rule 2 is for a century year. So the first thing is we need to identify whether the year is a century year or a non-century year. If it is a century year, a set of rule has to be applied, and if it is a non-century year, some other rule has to be applied. Now I have made the flow chart just according to that. Now what is happening in this case? Let's see. In this case, we are accepting the value of y. Y is my year. Now I will check whether y is century year or not. Now in order to check how y is a century year or not, we have to check whether it is divisible by 100 or not. Every value which is divisible by 100 has got a double zero at the end. So if y is divisible by 100, we are going to consider it as a century year. Now if it is a century year, towards yes when we are going to come, we are going to check whether it is divisible by 400 or not. Now if it is divisible by 400, it is a leap year. If it is not divisible by 400, it is not a leap year. In a similar fashion, if year itself is not a century year, then in that case we are going to go towards no. And when we will go towards no, we will find that year is divisible by 4 or not. If it is divisible by 4, we can figure out that it is a leap year. And if it is not, then in that case we are going to consider it as a non-leap year. So with this we can conclude that whatever is the input, we are implementing these two rules. Either rule number 1 or the rule number 2 must be followed if it is a leap year. So let us see how to write code for it. We are going to the IDE. We will check how we make the code for it. So now let me take you to the Python IDE where we are going to write the code. So here the Python shell is ready. Now we are going to take a function called isLeap, and what I'm going to do is I'll be taking the input for y, that is definitely going to be an integer because years cannot be taken in real numbers. So I'll write enter the year. Now here what I have to do is I have to implement the logic of checking whether the year is divisible by 100 or not. In my flowchart, I am going to take you to the flowchart once. In my flowchart, we have seen whether it is divisible by 100 or not, and then if it is divisible by 100, we have seen whether it is divisible by 400 or not. If it is yes, we said leap year, otherwise we said a non-leap year. Now in our Python code, we will have to take care of the margin specifically. So what we are going to do, let us see. If y mod 100 equals to 0. Now if it is equals to 0, then I am going to take it to the indented block. So here again what do I need to do? If y mod 400 equals to 0. Now see, the indentation is getting inside and inside. Now let me make it complete and then I'll discuss why this is looking like this. So if it is divisible by 400, I'll write it is a leap year. Now I don't need to do anything else in this case, but yes, if it is not divisible by 400, then in that case what shall I write? Print it is not a leap year. Now this part is done. Now I will be talking about the previous condition where I was checking whether it is a century year or not. Now I can copy the entire thing here and then paste it here, and just in place of making it 400, I can make it 4. Now that's all. Now you can see in this code what is happening. We have taken the input y, and one if is checking if y is divisible by 100, this whole thing is going to be checked, and if it is not divisible by 100, in that case this is going to be checked. That means in this case if block is containing another if block, and else is also containing another if block. Now this is known as a nested if else. Now when I'll call the function and then I will check, enter the year. So I'm going to check the current year, that is 2019. It is not a leap year. Again, if I want to check 2020, it is a leap year. In a similar fashion, if I want to check year 2000, that was a leap year. But let us see whether year 1700 was a leap year or not. No, it was not a leap year. Why it was not a leap year? Because it is a century year, but it is not divisible by 400. So this is how we can write this code. Now I will show you some other thing, because this is a program logic which is elaborated, and if you remember in the previous video I have discussed that one if can have two branches. Now definitely one if is like it's having two branches. One is if it is satisfying then, and one if it is not satisfying then. Now in this case ultimately we are having only two types of output. One is whether it is a leap year or it is not a leap year. Now I will take you to the flowchart once again to examine that. Now here you can see this case where the year is leap year. What we are figuring out, that year is a century year plus divisible by 400. Now tell me, if I check for whether the year is divisible by 400 or not, if it is yes, definitely year is divisible by 100 also. In this case what I actually want to mean is every value which is divisible by 400 must be divisible by 100. So do I need to check it is divisible by 100 as well as it is divisible by 400? No, because something which is divisible by 400 includes the condition which is satisfying, that is year is divisible by 100 also. So if I simply take that in this case the year is divisible by 400, then it is a leap year. Now next, when in the other case it is a leap year, when it is not a century year but divisible by 4, divisible by 4. Now in this case what is happening? See, we are coming to this condition when this is not satisfying. That means if I want to consider this, this is going to be if the year is not a century year but divisible by 4, it is a leap year. Now can we consider this thing? We can consider this thing very much in a very practical way. That means if I make a condition which is jointly going to check that the year is divisible by 400 or the year is not a century year but divisible by 4, it is a leap year. So for this, what do we get is, we get a different flowchart. So I'm going to show you the other flowchart. Now in this flowchart what you can see, what I was telling you, that year is not a century year and year is divisible by 4, or if year is divisible by 400 directly, we can straight away say that the year is leap year. Otherwise we can say it is not a leap year. So we don't require that large flowchart structure in that. We just can make a compound condition. Compound condition means where you are making multiple conditions come together to frame a single block of condition, which apparently will give you the same effect what the detailed structure was giving us. So what is the benefit of these type of, like, making it short? Making the things short like this makes your coding simplified and more readable. So let us now go and see how we can code according to this. So I will take you to the Python shell once again, and there we are going to check how the next function is going to be defined. So I am going to I need to make something different because I want to preserve the previous one also. So here I have taken it as isLeap1. So this is going to be my compound logic based program. So what I'm going to do is I'm going to take y equals to int input Now here I'll have to check this whole thing what I was doing earlier with so much of code. I will just write it in two compound conditions come together to frame one block of condition, that is y mod 400 equals to 0 or y mod 100 not equals to 0. Now what I have taken it as not equals to 0, because here I need to check that it is not a century year, and y mod 4 is equals to 0. In that case, let me complete the code, then I will tell you a few more things about how we have combined it with or and and. I will write here, I will write print the year is leap year, else year is not a leap year. So see, the same effect is going to happen. I'm going to check with the same conditions. I'll call leap isLeap 1 now. Now I'm going to check with 2019. That is not a leap year. It has given me the same output. Now if I run it once more, it is a leap year. Now I'm going to run it with 2000. It is a leap year. And when I'll be checking it with year 1700, let's see, it is not a leap year. So the condition are perfectly set here. So it is working fine. Now let us try to understand what I have written here. Now if you see, earlier when I was checking the program, I was writing all single conditions. Single conditions means single blocks, single statements which will be either true or will be false. Now here I have used some set of operator like or and and. Now what is the meaning of or and and? In general English, when we say or, that means it is either of the ones out of two. Say in a simple way, if I tell you that I need a pen or a pencil to write, and if you can provide me a pen, I'll be able to write. You will be noticing it that if you can provide me pen or a pencil, in both the cases I will be able to write. Is it clear? So or should be checked it in this way, that if this is satisfying or this whole block is satisfying, in any of the cases this is going to be true. This whole output is going to be true. Like I will be able to write if you can give me a pen or if you can give me a pencil, and if you can give me both, then also I will be able to write. So in what condition I will not be able to write? If you cannot provide me pen or a pencil. Now say for example, if you need to say I went to your home and you want to serve me a cup of coffee. Now for serving me cup of coffee, you need coffee as well as the cup. You need both. Now just think, you have cup in your kitchen but you don't have materials to make coffee. Will you be able to provide me? No. And in the similar way, if it is the opposite case, you don't have a cup but you have ingredients of coffee. So how will you serve me? Definitely you will feel to serve me without a cup. So let us take it in a very simple way, that in this case, if you consider and is type of a logical operator where both must be true if the outcome has to be true. That means you will be able to serve me in a proper way only when you have got a cup and you have got coffee. So in this case we have used both the ones. Now in this, whenever you have any expression and you have multiple operators, like you have one expression where multiplication is also there, addition is also going to happen. Now which one is going to happen first? There is a set of priority. We call it in mathematics BODMAS, BODMAS. But in this case also we have got some set of operators where there is a preset rule based on which it is decided which one is going to operate first. So out of logical operators, there are three logical operators. One is AND, next is OR, and third one is NOT. So here we are using AND and OR. So my friends, AND has got higher priority than OR. So in this case, what will be checked first? First, this is going to be checked. And if this satisfies, then this will execute. And if this does not satisfy, then this will be checked. And if this satisfies, then this will get executed. And in case if both don't satisfy, then in that case the year is not a leap year, will be executed. So this was one of the example where we have seen how to check whether the year is leap year or not. Now the purpose of this video was not just to explain what is a leap year or what is not a leap year. The purpose of this is to combine multiple conditions together to frame a smaller code which gives the same effect. Because writing these type of programs are a little confusing and it lacks readability. Whereas in this case, this is very simple and clearly understood, because you are reading it as if y is divisible by 400 or y is not a century year but a year divisible by 4. That's it. So take more such questions, try to implement this wherever you get a scope, keep trying, keep exploring, and if you find any difficulty, please put it in the comments below. I will definitely clear that in my upcoming videos. Thanks for watching. Please like it, because making a video for you becomes more inspiring and more motivating when we get like from you. So hit like, hit the bell button. More and more videos are going to be upcoming. You all will get notifications. Thank you. Happy coding.